Hello everyone, welcome to my next lecture video on equilibrium string problem. In the previous lecture we have talked about equilibrium sphere problem. So today we are going to discuss about equilibrium string problem. So here the first problem they are given the two cables which are tied together at C and are loaded as shown in figure. Knowing that alpha equal to 20 degree, determine the tension in cable AC and the tension in cable BC. So here what is happening in the problem, there are two cables which are tied at point C. The one is the cable BC and another one the cable AC. The BC has been tied at point B with making an angle alpha, that is which is equal to 20 degree, which is making with respect to horizontal as shown in figure. That is alpha equal to 20 degree with respect to horizontal as shown in figure. The same way the cable AC as tied at point A with an angle 40 degree with respect to horizontal. And also there is a load which is tied at point D, on the point D, which is having a weight of 200 kg, which is acting vertically downwards. So determine what is the tension which is available in the cable BC and AC. So to determine the tension in the cable AC and BC, so we have to draw the free body diagram. The free body diagram has been shown. Now, from the free body diagram, we know that there are three forces which are acting at a point. So by using the Lami's theorem, we can easily solve the problem. What Lami's theorem says, if any three forces which are acting at a point, then one force is directly proportional to sine of the angle between other two forces. So to apply the Lami's theorem, we require what is the angle between the two forces. So what is the angle between all the three forces, that we have to determine. To determine what is the angle between these particular force, what we should do, we should take the known angle. That is here, the angle between the cable BC and the self weight, that is the 200 kg they are already given. We can convert it into Newton by multiplying it with 9.81. So we'll get it in Newton. So to know what is the angle between these two forces, draw an axis. We know already, we know about the axis. So draw the x-axis and y-axis. So we know that the angle between the x-axis and the 200 kg weight Newton, which is 90 degree, plus there is an angle of alpha, that is 20 degree, which made by the tensional cable BC with respect to horizontal. So the cable BC which making an angle 20 degree with respect to horizontal. Or also you can consider it as the Z angle. What is the Z angle? So the two opposite angles will be equal. So what is the total angle now? The total angle between these two forces, which should be equal to, what? Which should be equal to 90 degree plus 20 degree. So here, from here to here it is 90, from here to here it is 20. So totally 110 degree. The similarly here the cable AC which making an angle 40 degree with respect to horizontal. So here from the x-axis to this point it is 90 degree, plus here it is 40, so totally 130 degree. So here it is 110 degree and here it is 130 degree. So what is the remaining angle out of 360 degree? So that is that in 360 degree the remaining is, we can say that 120 degree. That 120 degree will form here. So how the free body diagram of free body diagram will looks? The free body diagram will appear like this. You see here, the free body diagram of the figure will appear like this. So if you see here in free body diagram, the tension in cable AC has been made with an angle 20 degree with respect to the horizontal, that is as given here. The cable AC which makes an angle 40 degree with respect to horizontal has been given here, and a self weight which has been converted to Newton by multiplying 9.81. So the opposite angle is 110 degree between TBC and this one. TAC and this one is 130 degree, and TAC to TBC it is 120 degree. From the Lami's theorem, we know that if any one force, that is TAC, which is equal to the sine of the angle between the other two forces. So TAC is this force with the sine of the angle between the other two forces are this one. So TAC by sine 110 degree, which is equal to, this is TBC divided by sine of 130 degree, which is equal to, there is another force, that is 1962 Newton with an opposite angle of sine of 120 degree. So this is the Lamis theorem. Now using the Lamis theorem, we can easily determine what are the unknowns. First, what we do, first you should equate any one unknown force with the known force, that is 1962 by sine 120, which is equal to TAC by sine 110 degree. So we can easily get what is the unknown value, that is TAC. After that, next you equate the same TBC by sine 130 degree with 130 degree to 1962 by sine of 120 degree. Then you will get TBC. So the TBC and TAC are the tension in string AC and tension in string BC. So this is how we can calculate the unknowns which are present in the strings. Okay, similarly, if you move on to the next problem, we have to follow the same procedure. What is the problem? They are given the two cables are tied together at C, are loaded as shown in figure. Next, knowing that P equal to, there is a point C is there. In the C, there are two cables has been tied. The cable BC is making an angle 25 degree with respect to horizontal, and a cable AC which is making an angle 45 degree with respect to horizontal, and there is a one more unknown force, that is P is there, which is having a magnitude of 500 Newton and which is making an angle 500 Newton and which is making an angle alpha with respect to horizontal from the point C. So determine the tension in cable AC and BC. So to determine the tension in cable AC and BC, first what I have to do, first I have to draw the free body diagram. So first I am going to draw the free body diagram at point C. At point C, there is a cable BC which is acting towards this direction, which is making an angle 25 degree with respect to horizontal. So this is 25 degree. Next, the same way, the cable AC which is acting along this direction, which is also making an angle of 45 degree with respect to horizontal. So this is 45 degree. The same way, the at C, there is a one more unknown force which is having a magnitude of 500 Newton, and this 500 Newton force which is acting with an angle of alpha with respect to horizontal. So here the alpha they have already given us, which is equal to 60 degree in the question. So this is the free body diagram of the figure. Next, determine the tension in cable AC and BC. So here it is also same as the previous problem. After we have written the free body diagram, we have to check whether it is applicable for Lamis theorem. Yes, it is going to applicable for Lamis theorem because there is only three forces which are acting in a system. So we can easily determine the unknowns by using the Lamis theorem. If you see the free body diagram here, in the free body diagram, you see here TBC which is acting along this direction, which is making an angle 25 degree with respect to horizontal. Same way the TAC is making an angle 45 degree with respect to horizontal, and the load P which is making an angle 60 degree with respect to horizontal. Next, what we have to do, we have to know what is the angle between any two forces. That is, here it is 25 degree with respect to horizontal, and there is a 90 degree from x-axis to y-axis, and the remaining is 30 degree from here. So the total is 145 degree, and here it is 110 degree, and here it is 105 degree. Next, what you should do, you equate all the forces, that is TAC by sine of 145 which is equal to TBC by sine of 105 degree which is equal to P, that is 500 by sine of 110 degree. Equate any two equations or any two with one is known and another is unknown parameter. So then we can easily get the unknown parameter. Here we got the TAC and TBC value. It is same as the previous problem. So if you look at the one more problem, that is the one more problem here, the third problem which says that the two cables are tied at C point, are loaded as shown in figure, determine the tension in cable AC and BC. Right? To determine the tension in cable AC and BC, here what they have done, they have given the two cables, one cable BC which is making an angle of 75 degree with respect to horizontal, same way another cable AC which is making an of 75 degree with respect to vertical. So while drawing the free body diagram, first what we should do, first we should write the free forces, then you write the axis, that is x-axis and y-axis. Now from the axis we know that the TBC is making an angle 75 degree with respect to horizontal. So TBC is making an 75 degree with respect to horizontal. Same way TAC which is making an angle 75 degree with respect to vertical. So 75 degree with respect to vertical. Then you determine what is the angle between the other two forces. So then you can easily go for the free body diagram. The free body diagram figure will appear like this. So 200 kg they have already given. I converted into Newton. So the 200 into 9.81. So next TBC which is making 75 degree with respect to horizontal plus 90 degree from x-axis to this force. So totally 165 degree. From here this force TAC to the force which is already there as 75 degree. So totally the circle which has 360 degree, out of which if you deduct 165 minus 75 degree will get 120 degrees the angle between TAC and TBC. So next what we should do, we should apply it for Lambis theorem. If you apply it for Lambis theorem, that is TAC by sine 160 TAC by sine 165 degree which is equal to TBC by sine 75 degree which is equal to 1962 by sine 120 degree. So we can easily get the unknowns TAC and TBC value. Okay, we'll move on to the next problem. The next problem is based on the complete string. There is one string which has a loop of ABCD. We'll see the problem. A string ABCD is attached to two fixed points, that is A and D, as two equal weights 1000 Newton is attached at B and C. The weights are rest with the portions AB and CD at angles as shown in figure. Find the tension in the portion AB, BC and CD of the string if the inclination of the portion BC with the vertical is 120 degree. Here you see there is a one string which is present ABCD, the string which has been attached to two fixed points. So we can easily draw the diagram. So assume there are 4 points in a string. If you taken the string which has the 4 points, let me take this point as A and this point as D. They mention that in string ABCD is attached to two fixed points, that is A and D. When we know it is a fixed point, we can write the fixed symbol like this. All right. Next, the weights of 1000 Newton is attached to B and C. B and C. There is another 2 points are there. That is assume, just simply write it as B and C. B and C are the another 2 points which has been attached with the 1000 Newton load at B and C. Next, the weights are rest with the portion AB. So this is the weight where the rest with AB and CD. This is the D point, so CD. Inclined at an angle which shown in figure. At AB has been inclined with an angle of 30 degree with respect to vertical, and CD is inclined at an angle 60 degree with respect to vertical, that has been shown. Next, the remaining portion is BC. So they have mentioned that if the inclination of the portion BC with respect to vertical is 120 degrees, so this is the BC. So BC is making an angle 120 degree with respect to vertical. So determine what is the tension in the portion AB and BC and CD. So what we have to do, we have to calculate what is the tension in AB, BC and CD. So again I am repeating the questions. Here they mentions that ABCD is a string where A and D are the fixed parts and B and C has been hanged out with a weight of 1000 Newton, and the weight has been hanged in the portion AB which making an angle 30 degree and CD which is making an angle 60 degree with respect to vertical, and also BC has been inclined at an angle 120 degree with respect to vertical. So determine what is the tension at the portion AB, BC and CD. So how the free body diagram looks? So the free body diagram looks like this. If you consider at point C, there is a string which has been lead towards the D point, that is CD. Here at D point, actually at D point, the string has been making an angle of 60 degree with respect to horizontal, with respect to vertical. So if I taken the same thing and if I written here, it will be considered as Z angle. So this angle will also be equal to 60 degree. So at D point, which is this particular cable is making an angle 60 degree with respect to vertical. So this is the same angle 60 degree which has formed here. Now, from BC, in the cable BC, we know that BC has been inclined at an angle of 120 degree with respect to vertical. The BC has been inclined 120 degree with respect to vertical. So this is 120 degree from B to C. So I know that at B the remaining angle is the 60 degree here. So this 60 degree is the angle which formed from C to B. So if I consider this, so what it will be a Z angle. So the Z angle which makes that the 60 degrees making with respect to vertical at C point. So we can write the 60 degree here. So this is the 60 degree which is making with respect to vertical. Right, the remaining or else we can know that from B to C, which is making an external angle of 120 degree. So 120 degrees is this angle. So next, what is left? The left with this one. So totally 360 degree out of 250 degree has been gone. So the remaining is 120 degree. So this is the free body diagram at C point. The same way, if you draw the free body diagram at the point B, from the point B, totally there are three forces are there. One is the force BC, which is acting towards the C point, and self weight and retention in AB. So example, if I return the B point here, the self weight I will write, then I know that the tension in cable AB, which is making an angle 30 degree with respect to vertical. So if this is making an angle 30 degree with respect to vertical, the same vertical 30 degree will form here. So this is 30 degree. Alright. Next, there is a from B to C, which is making an angle of 120 degree with respect to vertical. They have already given. So this will be 120 degree. Right. So what is the angle between these two? That is 120 plus 30. So 150 degree here. So here it is from B to C, totally 120 degrees there. So the remaining is 60 degree. So here what is happening? Here the angle from here to here, which is 90 degree, and here already 30 degree has gone. So the remaining is 60 degree. So totally which is equal to 150 degree. So 150 degree, 60 degree and 20 degree is the angle between the forces. So the free body diagram at B and C will appear like this. So if you solve the problem by using the Lambis theorem, it will come like this. So by applying the Lambis theorem at point B, so we can know that from TAB, that is this whole divided by sine 60 degree, which is equal to TBC by this particular angle, that is sine of 150 degree, which is equal to 1000 by sine of totally 150 degree. So we'll get TAB and TBC. So we already obtained the value of TBC, so we can easily substitute the TBC value here. So TBC by sine of 120 degree, which is equal to TCD by sine of 120, which is equal to 1000 by sine of 120. So we can easily calculate what is the TCD value. Okay. Same way, the next problem. What is the next problem says? Knowing that alpha equal to 20 degree, determine the tension in cable AC and BC. So how to determine the tension in cable AC and BC? Here you see a truck which has been which is lifting a weight of 1200 lb, and it is holded by a rope by a man, and this man which making an angle of alpha with respect to horizontal. So what they are asking us to calculate what is the tension in the cable AC and BC. So to calculate the tension in cable AC and BC, first what I have to do, first I have to write the free body diagram. I'll take it as the C point. From the C point, this is the cable BC, the cable BC which making an angle alpha with respect to horizontal. So alpha value they have given as 20 degrees, so which is equal to 20 degree. And from the C point, there is a point which is making an angle of 5 degree with respect to vertical. So this is the 5 degree with respect to vertical, that is you can observe in the figure. So here you see the 5 degree which is making with respect to vertical. So, and there is a one more thing, that is the self weight, which is 1200 lb, which is acting vertically downwards. To convert from lb to Newton, if you multiply with 4.45, then you will get it into the Newton. So it will be equal to, how it will appear, the free body diagram of the particular problem will appear like this. So here you see the TAC, which is making an angle 5 degree with respect to vertical, and alpha, which is equal to 20 degree with BC, and also there is a self weight of 1200 lb. If you convert, it will appear to 5340 Newton. So this is how the solution of the problem will appear. So next, we know there are 3 points which are acting at a point which will be acting. So we can use the Lamis theorem. By Lamis theorem, we know that if 3 forces are acting at a point, so then we can take the opposite angle. So TAC by sine of 70 degree, which is equal to 5340 by sine of 115 degree, which is equal to TBC by sine of 175 degree. So we'll get TBC as this value and TAC as this value. Okay, the same way, the next moves on to the next problem. Here they are saying that an electrical light fixture weighing around 50 Newton hangs from point C by two strings, that is AC and BC. The string AC is inclined at 60 degree to the horizontal and BC is inclined 45 degree to the vertical. Shown in figure, using Lamis theorem or otherwise determine the forces in the string AC and BC. So an electric lamp which weighs around 50 Newton has been hanged at a point C by using two cables, that is BC and AC. The AC is making an angle 60 degree with respect to horizontal and BC is making an angle 45 degree with respect to vertical. So you can apply the Lamis, you can draw the free body diagram, then you can apply the Lamis theorem. So then you will get the unknowns like this. Okay, it is same as the previous one. So let me move on to the next problem and the last problem. So what it says, a light string A, B, C, D, E. Here you see a string which carries around 5 points or 5 nodal points whose extremity A is fixed. So they are mentioning that the point A has been fixed as weights W1 and W2, which is attached to it at B and C. So W1 and W2 are the weights which has been attached at B and C. It passes around a uh, it passes around a small smooth peg at D, carrying a weight of 300 Newton at the free end E. So they are saying that at E, there is a free end which is present, which is passed through a smooth peg, or we can call it as a pulley, over which it is hanged by 300 Newton weight. And they are mentioning that E is the free end. Now, is shown in figure, if in the equilibrium position BC is horizontal, they are mentioning that BC is the horizontal, and AB and CD, which is making an angle 150 degree and 120 degree with the BC. So calculate or determine the tensioning portion AB, BC and CD of the string and magnitudes of W1 and W2. So here you see it is very easy to understand the problem. They are saying that a light string which is having, there are 5 points A, B, C, D, E, and they are saying that the point A has been fixed. The first point A has been fixed, and which has weights W1 and W2 which are fixed at B and C. And also they are saying that BC is horizontal, so keep it BC as horizontal, and W1 and W2 has been fixed at B and C. So this is the point B and this is the point C. Next, they are saying that at E point is a free end where it has been hanged by a 300 Newton weight by using a small peg, a small smooth peg, that is called pulley, at D point, and which weighs around 300 Newton. And this particular cable CD and AB, which is making an angle of 150 degree with respect to 150 degree and 120 degree with respect to BC. So determine, this is how the diagram looks. So determine what is the tension in cable AB, BC and as well as CD. Along with that, determine the unknowns W1 and W2. So what we should do, first we should write the free body diagram at B and C. Here you see from point B, if I draw the free body diagram at point B, I know that there is a one self-weight, that is W1 is there, and from B to C, which has been exactly perpendicular to each other, and from B to A, which is having an angle of 150 degree with respect to C. So here it is 150 degree, and here it is the point B, and here it is the point C. So and here it is the point A, right? So totally the free body diagram at B will appear like this. Next, when the free body diagram at C, which will appear as how it will appear, the point D, which is moving towards the upward direction, as well as the weight W2, which is acting vertically downwards, and there is also one more angle or the force which is acting with respect to 120 degree from C to B. So what will happen? Here is that the force BC, which is horizontal, is the key point in the problem. So next, what we can do, by knowing the BC is horizontal, we after writing the free body diagram, so we can go for the solving the problem by using the equations like this. Here you see, by applying the Lamis theorem to the both B and C. So what we'll get here, you see the TBC by sine of 150 degree, which is equal to, one second, here you see TBC, that is the tension in the string TBC, which is equal to TBC by sine of 150 degree. This is the 150 degree angle, and W2 by sine of 120 degree, and 300 by sine of 90 degree. So sine of 90, which is equal to 1. So what we will get, 300 by 1 equal to W2 by sine 60 degree, which is equal to TBC by sine 30. That is sine of 180 minus theta. That is 180 minus 150, so sine 30 degree. So if you equate these two, we'll get TBC value as sine 30 degree into 300. So we'll get TBC value. Same way W2 will get 300 into sine 60 degree, so which is equal to 259.8 degree. Now from here we can observe that the value of the TBC has been obtained, which is 150 Newton, and W2 also obtained. So we can use the obtained value of TBC here. So what is TBC? TBC is 150 Newton, so I can apply it here. So TAB, what is, if you return the Lamis theorem for this particular problem, so TAB by this sine 90 degree, which is equal to W1 by sine 150 degree, which is equal to TBC by sine 120 degree. So TBC value we already determined as 150 Newton. If you substitute here, so we'll get the what is the value of W1, that is 86.6 Newton, and TAB by sine 90, which is equal to 1. If we equate it, we'll get TAB equal to 173.2 Newton. Okay, this is how we can solve the problem. The basic key thing is we have to draw the free body diagram properly, and we have to go for applying the Lamis theorem. So on the last problem, it says that the two cables are tied together at C, are loaded as shown in figure. Determine the tension in cable AC and BC. Here what is happening, there is a, if you see the free body diagram, a 500 Newton force which is acting towards the rightward direction, and TAC is making an angle 50 degree with respect to vertical, and TCB or TBC is making an angle 30 degree with respect to vertical. So 30 degree with respect to vertical. So apply the Lamis theorem and you can easily get the answer. TAC as 439.69 and TBC as for 326.35. Okay, it is same as the previous one. So thank you. We'll see in the next video.